What is Pascal's triangle?
Pascal's triangle, as the name implies, is a collection of numbers in the shape of a triangle. Each number in the triangle is the sum of the two directly above. For example, in the accompanying illustration, the 6 on line 5 is the sum of the pair of 3's above. The next line is 1, 10, 1 plus 9, 45, 9 plus 36, 120, 36 plus 84, and so on. Although the triangle was known to both the Chinese and the Arab cultures for several hundred years before, it was named after the person who brought it to the forefront of mathematics. French mathematician Blaise Pascal, 1623 to 1662. For more information about Pascal, see History of Mathematics.
How do astrologers perceive numbers in relationship to the solar system?
Astrologers, people who look at the universe in terms of how it affects human behavior and future events, perceive that each number from 0 to 9 is ruled by a certain celestial body in our solar system. Based on various factors, people are given certain numbers that then can be used to determine a person's dominant personality, and even his or her future. For example, the number 2 is ruled by the moon. A person with that number is cooperative, emotive, and has a great deal of feeling. The number 7 is ruled by Neptune, with the person being spiritual, and thus it is the number of mystics, visionaries, and seers. Not everyone subscribes to this way of knowing ourselves, but soothsayers have been around for centuries, finding numbers and sundry other cosmic quantities for people who believe in astrology.
What is the bathtub curve?
Industrial engineers usually know about the bathtub curve, especially in reference to an operating or failing unit. In other words, if enough units from a given population are observed operating and failing over time, it is relatively easy to compute week by week, or month by month, or year by year, estimates of the failure rate. The results of the calculated population failure rates over time produces a graph. Because the shape of this failure rate curve resembles the end-to-end section of an antique bathtub, it is widely known as the bathtub curve. This type of analysis is usually used in industrial settings. For example, it can describe the expected failure rate of certain electronics over time. Initially high, then dropping to 0 failures for most of the system's lifetime, then rising again to the other end of the tub as the electronics tire out.
How do numbers associate with each other?
Generally in mathematics, There are certain properties of operations that determine how numbers associate with each other. Closure is a property of an operation that reveals how numbers associate with each other. In particular, when two whole numbers are added, their sum will be a whole number. Closure as a property of multiplication occurs when two whole numbers are multiplied and their resulting product is a whole number. An associative property means that for a given operation that combines three quantities, two at a time, the initial pairing of the quantities is arbitrary. For example, when doing an addition operation, the numbers can be combined in two ways: a plus b plus c equals a plus b plus c. Thus, when adding the numbers 3, 4, and 5, this means that they may be combined as 3 plus 4 plus 5 equals 12, or 3 plus 4 plus 5 equals 12. Following the same logic for multiplication, the associative law states that axb, xc equals ax, bxc. In fact, in an associative operation, the parentheses that indicate what quantities are to be first combined can be omitted. An example of the associative law for addition is 3 plus 4 plus 5 equals 12, and for multiplication, 2x 3x 4 equals 24. But not all operations are associative. One good example is division. You can't divide in the same way as you added or multiplied above. For example, the result of dividing three numbers differs. The operation 96,012,04 equals 2 is not the same as 96,012,04 equals 32. Like the associative property, the commutative property is another way of looking at how numbers associate with each other in operations. In particular, this law holds that for a given operation that combines two quantities, the order of the quantities is arbitrary. For example, in addition, adding 4 plus 5 can be written either as 4 plus 5 equals 9 or 5 plus 4 equals 9. Or expressed as a plus b equals b plus a. When working on a multiplication operation, the same rule applies, as in axb equals bxa. Again, not all operations are commutative. For example, subtraction is not, as in the equation 6 3 equals 3. Which is not the same as 3 6 equals minus 3. Division also is not commutative. For instance, 603 equals 2 is not the same as 306 equals 1/2. The final property of an operation is the distributive property. In this rule, for any two operations the first is distributive over the second. For example, multiplication is distributive over addition. For any numbers a, b, and c, ax, b plus c, equals, axb, plus, axc. For the numbers 2, 3, and 4, you would have 2x, 3 plus 4, equals 14, or 2x3, plus 2x4, equals 14. Formally, there is a right and left distribution. Left is listed above, right is, a plus xc equals, axc, plus, bxc. In most cases, both are commonly referred to as distributivity. Again, not all operations are distributive. For example, addition is not distributive over multiplication, as in a plus, b x c, asterisk, a and b, x, a and c.
What are examples of polynomials with one root and no roots?
The following is an example of a polynomial with only one root, x2 plus 6x plus 9 equals 0, x2 plus 6x plus 6 halves, 2, 6 halves, 2 plus 9 equals 0, x plus 3, 2 9 plus 9 equals 0, x plus 3, 2 equals 0, x plus 3 equals 0, x equals minus 3. Or the polynomial has only one root, x equals minus 3, but not all polynomials have roots. The following is an example of a polynomial with no root, 2x2 6x plus 8 equals 0, 1 half, 2x2 6x plus 8, equals 1 half, 0x2 3x plus 4 equals 0, x2 3x plus, minus 3 halves, 2, minus 3 halves, 2 plus 4 equals 0, x 3 halves, 2 9/4 plus 4 equals 0, x 3 halves, 2 plus 7/4 equals 0, x 3 halves, 2 equals minus 7/4 because a real number squared is greater than or equal to 0, that means, x 3 halves, 2 will always be greater than or equal to 0. Thus, the answer can't be minus 7/4, a negative number, and there are no real roots for this polynomial.
What is the perimeter of a two-dimensional geometric figure?
The perimeter of a two-dimensional figure is what we perceive as the outside of the object. Mathematicians describe a perimeter more precisely as the sum of the lengths of a polygon's sides. The perimeter of a simple closed curve is measured as its length.
What is intuitionism?
There are some people within philosophy and mathematics who reject the formalism of mathematics and believe in intuitionism, which says that words and formulas have significance only as a reflection of the mind's activity. Intuitionists believe that a theorem is meaningful only if it represents a mental construction of a mathematical or logical entity. This is different from the classical approach that states that the existence of an entity can be proven by refuting its non-existence. For example, if you said A or B to an intuitionist, he or she believes that either A or B can be proved. But if you said, A or not A, this is not allowed. Since you cannot assume that it is always possible to either prove or disprove statement A.
How are studies of fluid mechanics used today?
The list of engineering uses of fluid mechanics in the modern world seems endless, and no wonder. Since it is one of the most widely applied areas of mathematics and engineering. Some of today's uses of fluid mechanics in various fields include, understanding the movement of molten liquid, rock, or lava, in volcanic eruptions, studying the flow of air over objects to help design airplanes. The space shuttle, and even spacecraft that fly through the atmospheres of other planets. Airflow studies in the automobile industry to design cars with more aerodynamic profiles, analyzing the ups and downs of the stock market. Examining natural hazards, such as snow conditions that result in an avalanche. Interpreting turbulent flow in sewer and water pipes, and in river channels. Studying complicated flow of weather patterns in the atmosphere, researching the effects of gravity, and other, waves in space. And using fluid mechanics applications to study the deep oceans and coastal shorelines, including waves and currents.
What is an asymptotic curve?
On a graph, a line that approaches close to a curve, or even an axis, but never quite reaches it is an asymptotic curve. In an example similar to one of Zeno's paradoxes, see Foundations of Mathematics. If a kitten standing a yard from a box walks half the distance to the box each hour, it will technically never reach the box. Because the distance it travels each hour is never more than half the remaining distance to the box. If this problem was illustrated as an equation, the answer would never quite reach its solution. A more mathematical example is the exponential function y equals 2x, which results in a line that approaches but will never quite reach the x-axis.
What do these philosophies tell about the state of modern mathematics and logic?
Like many abstract and complex studies, philosophies come and go. Some are good, some seemingly on the mathematical fringe. But they also show us that there is currently no single philosophy that truly defines our mathematical and logic foundations, especially when it comes to combining both mathematical knowledge and the application of mathematics to physical reality.
Who first made some of the first accurate measurements of the Earth?
Hellenic geographer, librarian, and astronomer Eratosthenes of Cyrene. 276 to 194 BCE, made several accurate measurements of the Earth, which is why he is often known as the father of geodesy, the science of Earth measurement. Although he was not the very first to deduce the Earth's circumference, Eratosthenes is thought by most historians to be the first to accurately measure it. Eratosthenes knew the sun's light at noon reached the bottom of a well in Syene, now Aswan on the Nile River in Egypt, meaning the sun was directly overhead, on the summer solstice. He compared it to a well's shadow at the same time in Alexandria. Knowing that the zenith distance, the angle from the zenith point directly overhead to the point where the sun was at noon, was 0 degrees at Syene. This meant that at Alexandria it was about 7 degrees. By measuring these angles and the distance between the two cities, Eratosthenes thence used geometry to deduce that the Earth's circumference was 250,000 stadia. The number was later revised to 252,000 stadia, or 25,054 miles, 40,320 kilometers. The actual circumference of the planet is 24,857 miles, 40,009 kilometers, around the poles, and 24,900 miles, 40,079 kilometers, around the equator, because the Earth is not completely round. From his data, Eratosthenes thence also determined another accurate measurement, the Earth's diameter. He deduced the Earth was 7,850 miles, 12,631 kilometers, in diameter, which is close to the modern mean value of 7,918 miles, 12,740 kilometers.
What is multiplication?
The word multiply comes from the Latin roots multi, many, and pli, folds.
How are angles measured in trigonometry?
Angles in trigonometry are measured using a circle on x and y axes, often called circle trig definitions. The radian measure of an angle is any real number 8, theta, see illustration.
How is wind speed measured?
Wind speed is most often measured using an anemometer. The simplest ones are made with cup-shaped devices that spin and catch the winds. The number of spins translates into an approximate value for the wind speed. The more accurate electronic anemometer has a free-moving turbine suspended in the middle of the instrument that, when held correctly, measures the wind speed. The speed of the turbine sensed by an infrared light relays the signal to an electrical circuit. From there, the wind speed is digitally displayed.
How do scientists use mean sea level in connection with global climate change?
Many scientists are interested in the long-term mean sea level change, especially in connection with global climate change. By taking such long-term measurements, these scientists are hoping to confirm the predictions of several climate models, including the idea that global warming is a result of the greenhouse gases from either human or natural sources. There are two major ways to determine such sea level variations. The first estimates sea level changes using tide gauge measurements, mathematically averaging the numbers. Graphs of the most recent estimates using this method show a 0.669 to 0.960 inch 1.7 to 2.44 mm, rise in sea level per year. The second method uses Global Positioning System, GPS, devices and satellite altimeter measurements, both of which accurately pinpoint global ocean heights quickly and more efficiently. For example, from 1994 to 2004, scientists mathematically constructed graphs from satellite altimeter measurements, showing that the global mean sea levels have risen anywhere between 1.10 and 1.18 inches, 2.8 and 3.0 millimeters. No matter what the method, scientists do know the global mean sea levels are slowly rising. Many believe that about 1/4 of the rise is caused by thermal expansion as the oceans warm, and another 1/4 by small glaciers melting around the world. Some rise may also be caused by such human activities as burning trees, pumping groundwater, and draining wetlands. Currently, scientists are not quite certain about the true rate of sea level rise, mainly because of the intensity of working on the data. Ocean tide gauge records must be averaged over many decades, and corrected for variable ocean dynamics and distortions of Earth's crust.
How did Jainism influence mathematics in India?
Jainism was a religion and philosophy founded around the 5th century BCE. Following the decline of the Vedic religion on the Indian subcontinent, along with Buddhism, it became one of the area's main religions. Over the next several centuries, Jainism also became a major influence in Indian science and mathematics. It was steeped in cosmological ideas in which time was thought of as eternal and without form. The world was also considered to be infinite and to have always existed. In fact, their cosmology included time periods with numbers larger than our modern guesses about the universe's age. Even their astronomical measurements came close to some of our modern values. For example, the synodic lunar month was thought to be 29 and 16/31 days. 29.51612903 days, the correct value is 29.53058888. Jainism also produced a plethora of mathematical ideas, some of which were surprisingly advanced for their time.
Why were counting devices developed?
Early counting devices were developed for a logical reason: to allow people to count items in order to trade or to keep track of stock, such as cattle. They also used simple counting devices to keep track of the seasons, mostly for agriculture, in other words, to know when to plant, and for religious reasons, such as marking days for certain feasts. For more about counting in ancient times, see History of Mathematics.
Why did the Egyptians need to develop mathematics?
probably the most pressing reason for the development of Egyptian mathematics, came from a periodic occurrence in nature, the flooding of the Nile River. With the advent of agriculture in the Nile River valleys, flooding was important. Not only to provide fertile soil and water for the irrigated fields, but also to know when the fields would become dry. In addition, along with the growth of the Egyptian society came a need for a more complex way of keeping track of taxes. Dividing property, buying and selling goods, and even amassing an army. Thus, the need for counting and mathematics arose. Along with the development of a written system of numbers to complete and record the myriad of transactions.
Who developed the first ideas on symbolic logic?
English mathematician George Boole, 1815 to 1864, was the first to develop ideas on symbolic logic. That is, the use of symbols to represent logical principles. He proposed this in his treatise, An Investigation of the Laws of Thought, on which are founded the mathematical theories of logic and probabilities, 1854. Today, this is called Boolean algebra. For more information about Boole, see algebra. For more information about symbolic logic, see Foundations of Mathematics.
Have computers been used to solve mathematical proofs?
This idea was first presented in 1852, when Francis Guthrie, 1831 to 1899, colored a map of English counties using only 4 colors. The idea of only 4 colors took on a mathematical bend and ended up being a theorem to be proved. It took until 1976, with the help of modern computers, before the 4-color conjecture was finally proven to be true. But some mathematicians are troubled by this computer proof, feeling that the theorem is so easy to understand that it should have been proven by hand. Thus, anyone who can prove the theorem without using a computer may win the Fields Medal, the math equivalent of the Nobel Prize. Another proof solved with computers is the double bubble. The double bubble refers to a pair of bubbles that intersect. They are also separated by a membrane bounded by the intersection of the 2 bubbles. This is similar to 2 bubbles stuck together when a child blows bubbles using a water and soap mixture. Since the ancient Greeks, mathematicians have worked on the problem of finding a mathematical proof of the efficiency of a single round bubble. The problem became even more rigorous when considering enclosing 2 bubbles or 2 separate volumes. The problem was solved around 1995 by mathematicians Joel Haas, Michael Hutchings, and Roger Schlafly. They used a computer to calculate the surface areas of the bubbles and found that the double bubble has a smaller area than any other when the enclosed volumes are the same. But this isn't the last word. Scientists are currently working on triple bubbles.
What is cryptography?
Because of the extensive connections between computers across the Internet, it has become necessary to find ways to protect data and messages from tampering or reading. This includes protecting people's personal information when they buy things over the Internet and those who need to keep banking data secure. One of the major techniques for ensuring such privacy of files and communications is called cryptography. Cryptography is a mathematical science used to secure the confidentiality and authentication of data sent by a user to a certain site. It secures the data by replacing it with a transformed version that can then be reconverted to show the original data, but only by someone with the correct cryptographic algorithm and key. This is why, when ordering over the Internet, it is important to see the lock icon at the bottom of the screen. This is your way of knowing that cryptography is working and the data is secure, thus preventing the data's unauthorized use.
Did the Babylonians finally use a symbol to indicate an empty space in their numbers?
Yes, but it took centuries. In the meantime, scribes would not use a symbol representing an empty space in a text, but would use phrases such as "the grain is finished" at the end of a computation that indicated a zero. Apparently, the Babylonians did comprehend the concepts of void and nothing, but they did not consider them to be synonymous. Around 400 BCE, the Babylonians began to record an empty space in their numbers, which were still represented in cuneiform. Interestingly, they did not seem to view this space as a number what we would call zero today, but merely as a placeholder.
What is a finite element analysis?
A finite element analysis, also known as FIA or finite element method, is a powerful tool to solve problems in engineering, especially for heat transfer, fluid mechanics, and mechanical system problems. The FIA consists of a computer model of a material or design that is stressed. The outcome is then analyzed for specific results. In reality, the computer is conducting a numerical analysis technique used for solving differential equations and relating it to stress in the engineering problem. This technique was first developed in 1943 by Richard Courant, 1888 to 1972. Who used a form of FIA to find approximate solutions to vibrational systems. Early in the 1970s, only companies that owned expensive mainframe computers were using FIA, including the aeronautic, automotive, defense, and nuclear industries. Since the mid-1990s, however, use of FIA has grown with the advent of faster and cheaper computers with more memory. The results are more accurate, too. allowing various industries to analyze new product designs and refine existing products.
What was de revolutionibus orbium coelestium?
In the year of his death, astronomer Nicolaus Copernicus, 1473–1543, in Polish, Miko/Loj Kopernik, published De Revolutionibus Orbium Coelestium, on the revolutions of the heavenly spheres. This manuscript gave a full account of his theory that the Sun, and not the Earth, was at the center of the solar system, or universe. Although this theory was not new, Copernicus offered the idea in all its mathematical detail. This heliocentric, versus geocentric, view of the heavens, now known as the Copernican system, is the foundation of modern astronomy.
Who developed the mathematical equations that explain electricity and magnetism?
One of the major early works about electricity and magnetism was written by Scottish physicist James Clerk Maxwell, 1831–1879. Who in 1873 published a treatise on electricity and magnetism theory of the electromagnetic field. These equations, now known as Maxwell's equations, include four partial differential equations that provided a basis for the unification of electric and magnetic fields. The electromagnetic description of light, and, ultimately, Albert Einstein's theory of relativity. Although most people recognize Isaac Newton's work on mechanics, few remember Maxwell's electromagnetic theories, including the idea of the electromagnetic wave, when it comes to classical physics.
How is the magnitude of a vector determined?
The magnitude of a vector is equivalent to the length of a vector. Placing a pair of vertical lines, similar to the absolute value symbol, around a vector implies the magnitude of the vector. For example, if the variable v is used to represent a vector, then the expression v indicates the magnitude of the vector.
What are functions?
Functions are mathematical expressions describing the relationship between variables and involve only algebraic operations. If there is one independent variable, the dependent variable, for example y, can be determined through the function. This is often seen written as y equals f, x, spoken as y equals f of x. Functions also use notation with x, for example, f, x, equals 2x plus 1 is a function. Functions within equations are also common, for example, in the equation x2 plus y equals 3, the y represents a function of x. This equation can also be written as y equals 3 plus x2. Functions do not always have to be in terms of f, x. They can just as easily be term g, x, depending on the equation. But note, the equation x2 plus y2 equals 9 is not a function, as x and y are both independent variables.
What are the different categories of modern calculus?
Modern calculus is divided into numerous types. The following lists just a few of these categories. Basic calculus. Basic calculus is the branch of mathematics concerned with limits and with the differentiation and integration of functions. There is also advanced calculus, which takes an even more complex view of calculus, with an emphasis on proofs. Differential calculus. Differential calculus deals with the variation of a function with respect to changes in the independent variable, s. It does this by determining derivatives and differentials. Integral calculus. Integral calculus, logically, deals with integration and its application to solve differential equations. It is also used to determine areas and volumes. Other various analyses. Other parts of calculus entail various types of analyses, such as vector, tensor, and complex analyses, and differential geometry. Also remember that the term calculus is a generic name for any area of mathematics dealing with calculation. Thus, arithmetic could be called the calculus of numbers. It is also why there are such terms as imaginary calculus, or a method of looking at the relationships between real or imaginary quantities using imaginary symbols and quantities. In algebra that do not mean the type of calculus discussed elsewhere in this chapter.
What type of numerals did the Egyptians use?
By about 3000 BCE, the Egyptians had a writing system based on hieroglyphs, or pictures that represented words. Their numerals were also based on hieroglyphs. They used a base 10 system of numerals, 1 unit, 110, 100, and so on to 1 million. The main drawback to the system was the number of symbols needed to define the numbers.
What is set theory?
Set theory is the mathematical theory of sets and is associated with logic. It is also considered the study of sets, collections of objects or entities. That can be real objects or intellectual concepts, and their properties. For more about sets, see below. Under formal set theory, 3 primitives. Undefined terms are used: S, the set; I, the identity; and E, the element. Thus, the formulas Sx, Xe, Xe mean X is a set. X is identical to Y, and X is an element of Y, respectively. Overall, set theory fits in with the aims of logic research. To find a single formula theory that will unify and become the basis for all of mathematics. As it turns out, sets lead directly to a vast amount of data encompassing all of modern mathematics. There are also a number of different set theories, each having its own rules and axioms. No matter what version, set theory is not only important to mathematics and logic but also to other fields, such as computer technology and atomic and nuclear physics.
What is chance?
Mathematically speaking, chance is a measure of how likely it is that an event will occur, a probability. For more about chance and probability, see Applied Mathematics.
What is projective geometry?
Projective geometry is a branch of geometry that deals with the properties of geometric objects under projection. It was formerly called higher or descriptive geometry. Projection includes the transformation of points and lines in one plane onto another plane. This is done by connecting the corresponding points on the planes using parallel lines similar to shining a light on a person's profile and producing a silhouette on a nearby wall. Each point on the wall is a projection of the person's head.
What are theorems, corollaries, and lemmas?
In mathematics and logic, a theorem is a statement demonstrated to be true by accepted mathematical operations and arguments. In general, a theorem is usually based on some general principle that makes it part of a larger theory. It differs from an axiom in that a proof is required for its acceptance. Some of the more well-known theorems are named after their discoverers, such as the Pythagorean theorem, involving right triangles, and Fermat's last theorem. It is interesting to note that American Richard Feynman, 1918 to 1988, one of the most brilliant physicists of the 20th century, stated that any theorem, no matter how difficult to prove in the first place, is viewed as trivial by mathematicians once it has been proved. Thus, according to Feynman, there are only two types of mathematical objects: trivial ones and those that have not yet been proved. A corollary is a theorem that has been proved in only a few steps from an established theorem, or one that follows as a direct consequence of another theorem or axiom. Finally, a lemma is a theorem proved as a preliminary or intermediate step in the proof of another more basic theorem, or it is a brief theorem used to prove a larger theorem.
What is computer science?
Computer science is, of course, the science of studying computers. It is the study of computation and information processing, involving hardware, software, and even mathematics. More specifically, it is the systematic study of computing systems and the computations that go behind making the computer function. Computer scientists need to know computing systems and methods, how to design computer programs, including the use of algorithms, programming languages, and other tools, and how software and hardware work together. They also need to understand the analysis and verification of the input and output.
What is a statistical test?
A statistical test is a procedure used to decide if an assertion, often called a hypothesis, about a population's chosen quantitative feature is true or false. These tests usually entail drawing on a random sample, or simple random sample, from the chosen population, then calculating a statistic about the chosen feature. From the result, a statistician can usually determine if the hypothesis is true, false, rare, common, or something in between. Overall, for a statistical test to be valid, it is necessary to choose what statistic to use, what sample size, and what criteria to use for rejection or acceptance of the tested hypothesis.
How are degrees and radians translated?
When measuring the number of degrees in a circle, another unit called radians is often used in trigonometry. It is known that a circle is 360 degrees, with 1 degree equal to 60 minutes, 60. And 1 minute equal to 60 seconds, 60. This is also called DMS, degree minute second, notation.
How are vectors used?
Any physical quantities, especially those in association with mathematics and science, can be represented by vectors, such as force, velocity, and momentum. In specifying these quantities, one must state not only how large it is but also in what direction it acts. Even more complex is the use of multidimensional vectors for such problems as relativity, wind velocities in an atmosphere, and in determining electromagnetic fields. A row vector is usually used for problem solving in which a vector is described as v equals x, y, z, during the specification of a problem. But note, row vectors should not really be used with any mathematical descriptions.
What is orbital mechanics?
Orbital mechanics, also called flight mechanics, is the study of the motions of artificial satellites and Space vehicles moving under the influence of forces such as gravity, atmospheric drag, thrust, and so on. It is a modern spin-off of celestial mechanics, or the study of the motions of planetary and celestial bodies. One of the main scientists who built the foundations of orbital mechanics was mathematician Isaac Newton. 1642 to 1727, who put forth his laws of motion and formulated the law of universal gravitation. For more about Newton, see History of Mathematics and Mathematical Analysis. For more about Newton's laws, see Mathematics in the Physical Sciences. Today's aerospace engineers apply orbital mechanics to such problems as rocket and spacecraft trajectories, re-entry and landing of space vehicles, rendezvous computations, such as the Space Shuttle to the International Space Station, and lunar and interplanetary trajectories for manned and unmanned vehicles.
How are statistics used in industrial engineering?
Industrial engineers study the efficient use of personnel, materials, and machines in factories, stores, repair shops, and offices. They prepare layouts of machinery and equipment, plan the flow of work, make statistical studies, and analyze production costs. In particular, they rely heavily on a branch of mathematics called statistics and probability. For more about statistics and probability, see Applied Mathematics.
How is air temperature measured?
Simply put, there are two ways to look at air temperature, on the microscale. It is the small-scale measure of gas molecules' average kinetic energy. On a larger scale, it is the action of the atmospheric gases as a whole. In physics, an entire branch is devoted to objects' temperatures, and the transfer of heat between objects of differing temperatures. Called thermodynamics, it is a study that entails a great deal of mathematical knowledge. No matter what the type of temperature discussed. The most common apparatus for measurement is the thermometer. The most familiar thermometers are thin, long, closed glass tubes containing some type of liquid, most often alcohol or mercury. When the temperature increases or the air around the tube heats up, it causes the liquid to expand, moving it up the tube. Air temperature measurements are most commonly read in centigrade or Fahrenheit. For more about centigrade, Celsius and Fahrenheit, see Mathematics Throughout History.
How have computers been used to factor large composite numbers?
Computers have often been used to factor large numbers, and not just by number theorists having some fun. In fact, factoring such numbers has helped to test the world's most powerful computer systems, to promote designs of new algorithms, and in cryptography used by people who need to protect sensitive information on their computers. For example, in 1978 several computer experts proposed using the reconstruction of the prime numbers from the product of two large prime numbers as an encryption technique. This method of encrypting sensitive data soon blossomed, especially because of the needs of the military and banking industry. The public also reaped the benefit of this idea as it eventually led to encryption. Methods such as the public key encryption for banking and personal pages on the Internet.
What mathematical concept is used to calculate mortgage payments?
In most cases, a mortgage is based on amortization, which is the gradual elimination of a liability. A financial obligation or debt, such as a mortgage, in regular, fixed, systematic payments, such as monthly, over a specific period of time. These payments must be enough to cover both the principal borrowed and the interest. Although it is usually written in a complex set of mathematical calculations, simply put, amortization means a part of the payment goes toward the interest cost and the remainder goes toward the principal, or the amount borrowed. The interest is then recomputed on the amount owed, and therefore it gets smaller and smaller as the ending balance of the loan becomes less and less. That is why the homeowner pays a great deal toward interest and not the principal for the first several years of a home mortgage. For example, if a mortgage is taken out for $100,000 at 6.5% for 30 years, the fixed monthly principal and interest payment is $632.07 for the first month. The homeowner pays interest on the $100,000, or $541.67, with the remainder of the payment, $90.40, going toward principal. In other words, the debt on the principal is reduced by $90.40. By the next month, the homeowner owes interest on a lesser amount of money on $99,909.60, or $100,000 $90.40. Not the $100,000 with $541.18 going toward interest and $90.89 going toward principal. As payments are made month after month, the interest decreases and the principal reduction increases. By the 360th payment, or 30 years later, the payment contributes $3.41 to interest and $628.66 to principal.
What was the golden age of logic?
Ert Gödel's work led to what is often described as the golden age of logic. Spanning the years from about 1930 to the late 1970s. It was a time when there was a great deal of work done in mathematical logic. From the beginning, mathematicians broke into many camps that worked on various phases of logic. For more information about logic, See Foundations of Mathematics, including proof theory, in which the mathematical proofs started by Aristotle and continued by Boole, CP 30, were extensively studied, resulting in branches of this mathematics being applied to computing, including artificial intelligence. Model theory, in which mathematicians investigated the connection between the truth in a mathematical structure and propositions about that structure. Set theory, in which a breakthrough in 1963 showed that certain mathematical statements were undeterminable. A direct challenge to the major set theories of the time. This showed that Cantor's continuum hypothesis, CP 31, is independent of the axioms of set theory, or that there are two mathematical possibilities. One that says the continuum hypothesis is true, one that says it is false. Computability theory, in which mathematicians worked out the abstract theorems that would eventually help lead to computer technology. For example, English mathematician Alan Turing proved an abstract theorem that established the theoretical possibility of a single computing machine programmed to complete any computation. For more information about Turing and computers, see P34 and Math in Computing.
What are the conditions in reference to differential equations?
In general, there are two conditions when discussing differential equations.
What is a truth table?
A truth table is a two-dimensional array of truth values derived by determining the validity of arguments through assigning all possible combinations of truth values to the statements. This simple form of logic depends on a combination of certain statements. Using terms such as not or and, along with the input values. The first columns correspond to the possible input values and the last columns to the operations being performed. The rows list all possible combinations of true, t, or false, f, inputs, together with the corresponding outputs.
What are logic puzzles?
In general, a logic puzzle involves the description of an event or contest. It is derived from the mathematical field of deduction. Clues are provided and the puzzle player has to piece together what actually happened by using clear and logical thinking, thus the name. One of the most famous logic puzzle pioneers was writer, photographer, mathematician, and illustrator Charles Lutwidge Dodgson, 1832–1898, otherwise known as Alice's Adventures in Wonderland author Lewis Carroll.
What are the probability and odds of drawing a certain card from a deck?
The probability of an event is usually described as the chances for the event to occur over the total chances for the event to occur, chances for/total chances. In the case of a deck of 52 cards, the probability of drawing a king from the deck is 450 seconds equals 1/13 equals 0.077, or 7.7%. As seen above, the odds, or the ratio of chances for to chances against, chances for, chances against, can be found by the formula, total chances equals the chances for plus chances against. Or total chances equals chances for plus chances against, or chances against equals total chances for. Thus, the odds of picking a king from a deck of 52 cards is 452 4, equals 448 equals 112.
What are some examples of Egyptian multiplication?
Egyptian multiplication methods did not require a great deal of memorization. Just a knowledge of the 2 times tables. For a simple example, to multiply 12 times 16, they would start with 1 and 12. Then they would double each number in each row. 1x2 and 12x2, 2x2 and 24x2, and so on. Until the number 16, resulting in the answer 192. Another example computes a number that is not a multiple in the row, such as 37 times 19. First, do the usual procedure by starting with 1 and 19, then doubling the numbers until you get to 32. If you double 32 equals 64, you've overshot the number 37. Because 37 is higher than 32, go back over the list on the left-hand side, figure out which numbers. With 32, add up to 37, 1, 4, and 32, then add the numbers that correspond to those numbers. To the right, 19, 76, and 608, which equals the answer, 703. And you didn't even need a calculator.
What is the law of total probability?
The law of total probability can be written as follows: the probability that an event A will occur, P, A, is equal to the probability that event A and event B both occur, plus the probability that event A and event B occur, or A occurs and B does not. Using the multiplication rule, this is written as P, A, equals P, AB, P, B, plus P, AB, P, B.
What does borrow mean in subtraction?
As with carry in addition. To borrow in subtraction means to take amounts from one number and assign them to the next. In this procedure, the 10 is borrowed from the next highest digit column in order to obtain a positive difference in the nearby column. When you subtract the same columns, starting in the right-hand column, the 4 is too small to subtract from 7, therefore, you need to borrow 10 from the column to the left. Boosting the number 4 to 14. The column to the left then loses 10, and 2 is left. Again, the 2 is too small to subtract from 6, so 10 is borrowed from the next column to the left. Boosting the number 2 to 12. The last number to the left is dropped down by 10, giving 11, the 5 is subtracted from the 11, resulting in 6 in that column.
What were Aristotle's syllogisms?
Syllogisms, which are often attributed to Aristotle, are the verbal versions of the formal deductive rules for logic. Aristotle believed that any logical argument could be explained in these standard forms. He divided them into a major premise, all squirrels eat nuts, a minor premise, Fred is a squirrel, and a conclusion derived by a rule of logic, Fred eats nuts. The classical syllogism is, all men are mortal. Socrates is a man. Therefore Socrates is mortal. This form of logic called syllogistic logic would dominate Western cultural thought for more than 2,000 years.
What were the major reasons for 16th century advances in European mathematics?
There are several reasons for advances in mathematics at the end of the Middle Ages. The major reason, of course, was the beginning of the Renaissance. A time when there was a renewed interest in learning. Another important event that pushed mathematics was the invention of printing, which made many mathematics books, along with useful mathematical tables, available to a wide audience. Still another advancement was the replacement of the clumsy Roman numeral system by Hindu-Arabic numerals. For more information about the Hindu-Arabic numerals, see Math Basics.
What is the definition of a conic section?
This family of curves first discovered, as far as we know, by the ancient Greeks is generated by planes intersecting, cutting into, a cone. The resulting feature depends on the angle between the plane and the axis of the cone, with none of the planes passing through the endpoint, vertex, of the cone. Each plane that cuts a cone creates a two-dimensional figure called a section. Thus the resulting figures are called conic sections or conics. In general, the possible resulting surfaces are a sphere, the cut perpendicular to the axis, ellipse or the circle as a special case, a cut moderately inclined to the axis, parabola, a cut parallel to one of the straight lines that generate the cone, and hyperbola. Using two cones tip to tip, the cut even more steeply inclined than all the others.
Who was the first recorded female mathematician?
The first known female mathematician was Hypatia of Alexandria, 370 to 415. Who was probably taught by her mathematician and philosopher father, Theon of Alexandria. Around 400, she became the head of the Platonist school at Alexandria. Lecturing on mathematics and philosophy. Little is known of her writings, and more legend is known of her than any true facts. It is thought that she was eventually killed by a mob.
Can a fraction's numerator be 0?
And the context of division, see above, we learned that it is not possible to divide by 0, which is labeled an undefined number. But you can have 0, 0, as your numerator, and any allowed fraction, one that doesn't have a 0 in the denominator. That has 0 as its numerator will always be equal to 0. For example, 0/5 and 0/345 both equal 0.
How many bases are in a human's genome sequence?
Here's a good reason why computers are so important to biologists working on the human genome. The amount of data is staggering, and would take scientists generations to analyze without the benefit of computers. For example, it would take about 9.5 years to read out loud. Without stopping, the 3 billion bases in a person's genome sequence. This is calculated on a reading rate of 10 bases per second, equaling 600 bases per minute. 36,000 bases per hour, 864,000 bases per day, and 315,360,000 bases per year. 1 million bases, called a megabase and abbreviated MB, of DNA sequence data is roughly equivalent to 1 megabyte of computer data storage space. Because the human genome is 3 billion base pairs long, 3 gigabytes of computer data storage space are needed to store the entire genome. This includes something called nucleotide sequence data only and does not include other information that can be associated with sequence data. Because of such numbers, scientists working on the human genome are grateful they have computers on their side.